Find the sum to n terms of the following series. Let us begin. So here we have a series whose first term is 3, followed by 5, then we have 9, added to 15, plus 23, and the rest of the terms. Now clearly this is not an arithmetic series, nor it's a geometric series, for it does not have any common difference, nor does it have any common ratio. However, we see a pattern here. If we take the second term, which is 5, and from here subtract the first term, that's going to give us 2. Then we take the third term, which is 9, and from here subtract the second term, so that's going to give us 4. 15 minus 9, that means the fourth term minus the third term, that's going to give us 6. And 23 minus 15, that's going to give us 8. Now as we can see here, 2, 4, 6, 8. Now these terms are clearly forming an arithmetic progression. Now, if they're forming an arithmetic progression, so this is a hint that we will be using to solve this problem. So what we'll do, we'll consider that let Sn represents the sum to n terms of the given series, where the last term is going to be denoted by Tn. And then if Tn is the last term, then we can also define its second last term as Tn minus 1. Okay, now what we'll do, we'll again take the same sum Sn and let's write the terms here. So we have 3 plus 5 plus 9 plus 15, and this goes all the way up to the second last term, which is Tn minus 1, following the last term, that is Tn. Okay, we're going to perform a subtraction here. On the left hand side, Sn minus Sn, that's simply going to be equals to 0. We keep the first term as 3 only, but we are now going to subtract 3 from 5, that gives us 2. 9 minus 5, that's 4, 15 minus 9, that's 6, 23 minus 15, that's 8, and then we have Tn minus 1, and then we have negative Tn. So transposing this negative Tn to the left hand side gives us positive Tn. This is going to be equals to 3 added to. Now let's consider the second last term all the way up to Tn minus 1. So this is going to be an arithmetic series, and we know the sum to the n terms of an arithmetic series is given by a standard formula n over 2 multiplied to 2 times the first term added to the total number of terms minus 1 multiplied to the common difference d. Now in our case, we have the first term. So here the first term, that's equals to 2. The common difference, that's also equals to 2. And how many terms are here? So there are in total of n minus 1 terms. Now let's try to understand why there are n minus 1 terms and not n terms. If we consider the first sum Sn, we excluded the first term 3 during subtraction. We considered only the second term all the way up to the last term Tn. So by definition, Sn has got n number of terms. If we exclude any one term, it's going to be left with an n minus 1 number of terms. Similarly, in the second sum Sn, so we have considered the first term all the way up to the second last term. So here we excluded the last term Tn. That means this one is also going to have n minus 1 number of terms. Now clearly, when we subtract one n minus 1 number of terms from the other one, that's going to leave us with n minus 1 number of 1 terms. Now our formula is going to become n minus 1 over 2. So what we'll do, we'll replace this n value with n minus 1. This will get multiplied to 2 times the first term, so that's 4, added to n minus 1 minus 1, that means we have n minus 2 multiplied to the common difference, that is 2. So this comes out to be equals to n squared minus n plus 3. So we have obtained the nth term of the series. Now we can use this nth term to obtain the sum up to the n term, which is defined as the summation of the nth term, where we have replaced the index n with k, and k is going to run from 1 to n. And that means we have to find out the summation of k squared minus k added to 3, with k going from 1 to n. Okay, so let's find out the sum. So here we have summation k squared with k going from 1 to n. Next, minus, we have summation of k going from 1 to n, added to 3 times summation of 1 with k going from 1 to n. Now we have a standard formula for finding out the summation of each of the 3 summation. So starting with summation k squared, that is the sum of the squares of first n natural number. The second one is the sum of the first n natural numbers. So we have n multiplied to n plus 1 multiplied to 2n plus 1 whole divided by 6 minus n times n plus 1 divided by 2 added to 3 times n. Okay, so we're going to combine all of them, and that's going to finally give us n multiplied to n squared plus 8 whole divided by 3. So this is going to be the sum to n terms.